So that's correct. The 4 is a perfect square, so we automatically move it out front. And then we ask ourselves, 4 times what number gives me 12? And that's 3, which is left behind. The number part makes sense so far?
Yeah, I understand the number. It's just
So the variable's next, right? So, Jim, we went through this rule, and if everybody else is having trouble with this, because on the quiz, some people have struggled with this. We went through this thing, and in class we recognized that whenever there was an even exponent, it worked out well because there's really a 2 as an index there. We talked about that. We said, you know what, let's take out as many even amounts of the variables we can. So I can take out x squared or x to the 4th out of here. It doesn't matter either one. But if I take out x squared, I'm left with x cubed, which has another x squared, right? So I have to do it again. So our goal in all these problems is to take out the largest perfect square. And in this case, x squared or x to the 4th are perfect squares. But x to the 4th is the larger of the two. Now, if we had something where x was with a cube root, then this has to be a multiple of 3. If it was a 4th root, then this has to be a multiple of 4. So the idea is that whatever the index is, you take out a multiple of that in the variable for the exponent. So if it was x to the 4th, you could take out, if it was the 4th root of x, you could take out x to the 4th, x to the 8th, x to the 12th, etc. Any multiple of the index. So that's your simple answer. And the idea is that you want to get the largest one out. So this is really a 2 here. It's not shown with square roots, but there is a 2. So I'm going to take out 4 of these and leave 1 behind. And then I go ahead and simplify. And how do I simplify these again? What do I do? What's the quick way to do it, Julian?
Bring 4 down to 2 and x to the power of 4 down to x squared.
Yeah. And why is that, Julian? Why can I make that x squared? What's the idea there?
Basically, that's x squared by x squared is equal to x to the power of 4, so that would be its.
And what's the easy kind of not mnemonic, but trick? I don't want to use the word trick. What's the easy way to get the answer for the outside if it's not as obvious as Julian noticed? What do we do?
Since it's a variable, you can just divide that number by 2.
Yeah, by the index.
Yeah.
So write this down if it didn't click automatically, right? You take the power and simply divide it by the index, and that's what comes out here always. And if you want to go through why that is, we've done that, and we went over that in section 4142, I think. And then in 5152, we quickly discussed the idea of these. So we saw this happening 6162. We saw this happening a couple times where the index is the thing that divides into the power. And we'll see that for all of these problems. So no matter what you have, x to the 5th with a cube root, I simply take this 5 right here and say, how many can come out? Only 3 can come out here. There's a cube root of x cubed. Now, x squared doesn't work. I leave it alone. And then I simply take 3 divided by 3 here. And that simply becomes x. Why don't I need absolute value around this right here? Why don't I need absolute value? Okay?
Because it's squared, and if you square numbers, it's going to be positive.
Correct. Remember, we are simplifying expressions with square roots. So we're only using the principal root. Notice I didn't put plus or minus 2 here. If I solved an equation that said the square root of 4 is equal to x, then x would equal plus or minus 2. But this is not an equation, it's an expression. So it's a principal square root. Therefore, we want this to be positive. And since it's squared already, it's going to be positive. We don't have to worry. Okay? Anything else on this question or this idea?
No.
I'm going to go to John next. He was next, and I'll come to you, Sean. Go ahead, John.
My question is section 61, problem 20.
Hold on, I got it right here. Number 20, we're looking at a binomial in the denominator, and that binomial has radicals in both pieces. Is this right, John? This one?
Yeah.
Okay. So when I look at this problem, I ask myself, how do I get rid of a radical in the denominator? Now, if the radical didn't have a binomial, or if the denominator was not a binomial, and yet it were a monomial, how would I approach it? Let's start with that.
We multiply.
So let's make believe this is not here, or say,
Yeah,
I guess this doesn't work well for this case.
We
These
multiply
both-
the whole expression by the denominator.
Yeah, you multiply by itself.
Numerator.
So if this were just a radical 3, make believe these weren't divisible. I know that would cancel. If this were just a radical 3, you would multiply by root 3 over root 3. Now we've done that in the beginning of rationalization. And then we recognize that, oh, these things called binomial conjugates also work nicely. Because the binomial conjugates, the middle terms, cancel out, so we end up with a real, in this case, a rational denominator. So what's the binomial conjugate of this part? What do I have, though?
Root 2 minus root 3.
Root 2 minus root 3. And root 2 minus root 3. So I multiply that by that over itself. And then the key is to remember to put this in parentheses. Okay, and to remember to distribute the numerator. I personally, if I were taking a test, I wouldn't do this, but in my mind, I see these in parentheses, and I think of FOIL every time. It doesn't make sense not to, right? The whole premise behind this is that when this is FOILed out, the outer and the inner terms cancel. So if you don't FOIL it out, that's not going to happen, and you're not going to get the simplification that you want. So it just makes sense and is logical. The numerator, we just have to remember to distribute to both. And then it becomes a simplification game, right, at that point? So we have to do a lot of simplification. Root 12 minus root 18 all over. And remember, insides multiply insides. There are no outsides in this problem. There are no coefficients. So I don't have to worry about like a 2 out here and a 3 here. But if they were there, the 2 outside here would multiply by the 3 as a coefficient, not an index. Talking about coefficients. So we have to remember insides, insides, outsides, outsides. So when I FOIL this out, I'm just doing the first term, which is really root 2 times root 2. By now, can I just say that that's just 2? Everybody understand that, right? I've been showing root 4, but then it becomes 2 anyway. And then root 3 times root 3 is just 3. Now I have to carry the minus sign because it's positive and negative, and I'm multiplying those things, so that's a negative 3 there. So this is what I end up with, and then I want to simplify this a little bit further. So this becomes root 4 times root 3 minus root 9 times root 2 all over negative 1, which can be simplified a little bit further. The numerator becomes 2 root 3 minus 3 root 2 all over negative 1. If I divide by negative 1, what should I just do with the numerator if it's a subtraction problem?
You should just inverse it and do root 2 minus 2 root 3.
Correct. Switch the order. Be careful with the word inverse. Switch the order. That means this, right? So switch the order of the numerator's terms, the binomial terms, from dividing by negative 1. Okay? Is that clear?
Yes.
And again, if the denominator had not been a binomial, just multiply by itself over itself. How about this one real quick? Because this is on the same topic. If I had 3 over 2 root 7, what do I multiply the top and bottom by?
Root 7.
Good. Not 2 root 7. You can do it, and it's fine. You wouldn't be wrong. But you would be adding another step of simplification by putting a 2 there also. You would multiply out, and you would reduce by 2. So yes, you just use the irrational portion.
Oh, so you just use the radicals when you multiply?
Correct. Okay? Versus if this were a plus sign here, then you'd have 2 minus root 7, 2 minus root 7, like that, right? Okay, but it's not a plus sign there in this case. Any other questions on this topic, neighbor?
Question on the problem.
So Sean, and then you go ahead. Go ahead, Sean.
Okay, number 36 of 6.2.
Six, 36. The messy one, of course, yeah. So it says, simplify. Assume that each radical represents a real number. And if each radical represents a real number, that's our stipulation that the variable has to be positive, which is where the absolute value is going to come into play. Okay, so again, it says y squared times the square root of 45y plus 2y times the square root of 5y cubed. Now, the first thing to recognize is when they say, or when your directions say something like, the radical represents a real number. Real numbers only occur when the radical is, what's the word? Real numbers.
Greater than 1.
Greater than?
Greater than 0.
0. Greater than or equal to 0, right? Positive for the most part. So what they're saying in the directions that this is positive. The only way for this to be positive is if y is positive. So we know already from the get-go that y is absolutely positive in this case. So it's good to keep that in the back of our mind. Now, from this point on, we just want to simplify this. The left one, I could just break into 9 and then 5y. and the y stays behind. And the right one, I could break into y squared and 5y. And notice the common radicand. This is not something that is going to be a coincidence. For the most part, if a problem can simplify, the radicand has to be common. So you could expect that. Now, there can be a problem where you might have an answer where the radicand isn't the same, and you have to leave it like that. So don't let that confuse you. I'm not trying to goad you in one way or the other. I haven't even made your test yet, honestly. I have not. So I'm giving you an idea that, like, you never know. You could end up with like a 3x and a 5x here, and then you cannot combine terms as a result. So just keep that in the back of your mind. But you want to look for that is the idea. So this is y squared times 3 times root 5y plus 2. Now, again, the assumption already is that this was a positive value. In the beginning of the problem, it was stated that this was a real number, so this must be a positive value. So if I take a y out of here now, I don't need the absolute value because of the fact that it absolutely is a positive number already from the earlier statement. So I know that this will be a positive number. I'm going to multiply these two together. I've already got 3y squared. I'll have 2y squared. I can then combine my like terms. So what did I say yesterday, I think it was, with the quiz? Think of this and this as your variable. It's 3 times that thing plus 2 times that entire thing, yielding 5 of those things. And I'm using the word things on purpose, obviously, right? Because I'm trying to get at the point that, yeah, you have a set of variables here, all multiplied. That itself is like one variable. I could think of this as 3u plus 2u, and that would yield just simply 5u. So in this case, 3 of these plus 2 of these is 5 of these. And these, in this case, are y squared root 5y. Okay, y squared root 5y. Does that make sense?
Mm-hmm.
And answer, what was the question you had? I'm curious.
I just messed up my initial simplification.
Okay. And by the way, I mean, I'm not giving you any like Andrew, by the way, let's say, so you listen. On the quiz, one of the things I did notice is that happened a lot. If you make a mistake in the initial simplification, it's going to carry through the problem, right? So when you get to the point of the problem where it just looks too messy and nothing can be done, go back to the beginning and find that mistake. There's a good chance it's there. Okay?
There won't be problems like that where they're like insanely messy. Wait,
Like this, you mean, right here?
No, that was.
That
Yeah,
wasn't
that
too
was-
messy. But you mean like ones where there's like a ton? I mean, I'm going to try not to, but there's not too much I can test you on this test, if you think about it. It's the only test without word problems this year. So instead of word problems, you could expect a couple complicated problems at the end where you have to simplify stuff. So maybe like laws of exponents where there's like 3 or 4 terms with a negative exponent, with other weird exponents in the middle, powers to powers inside with a negative. So you can maybe expect that at the end instead of the word problems, okay? Because of that. So you have the next question, unless it's on this.
Oh, no,
So we'll go Andrew, then I'll tell you, unless it's on this.
I have a question about the test item. Is there going to be a calculator portion of it or no?
Yeah, same as all tests. It'll be half and half, most likely, or a portion and a portion. Andrew, what question?
6.435. I don't know if I got it right. I did the quadratic formula and I don't.
So the quadratic formula gives you the answer, right? And you got the answers that were shown there? Is that correct?
Kind of.
Okay, now, and that's fine. You're proving that this has a solution of 3 plus root 5 and 3 minus root 5. But if you carefully read the directions here, it says substitute into the equation to prove.
Yeah, I know how to do that.
How do you check an answer? You just plug it back into the original, right? These are both answers. Plug them in, but one at a time. The common mistake is that students put this in here, and then they put this in here. So you take this one answer, remember there's 2 answers because it's quadratic. You take one of the roots and plug it in where you see x. The reason I do this, Andrew, is so you practice foiling with binomials that contain radicals. That's the only reason this problem is in this section. It's also a little preview of what you're going to see in chapter 7. But you do not have to use the quadratic formula to get these answers, yet instead you need to take this quantity, plug it in here and here, and when you do that and simplify, you'll get 0 equals 0, which proves that that is correct. And then you do the same thing with the second root, plug it in those spots, and you need to get 0 equals 0. Anybody else have a question on that one? Because that one was tricky if you didn't know what to do. But that's all you're doing. Like solving check, you're just doing the check. Okay?
I have a question on 6-1, number 30.
$35. For what values of x does the expression represent a real number? This is a good one. So we've got the square root of x cubed minus 9x. We want this expression to be real. So Nick told us a little while ago, what makes a value real when we're looking at the radicand for a square root, not a cube root. Remember, cube roots can be negative, positive, anything. For a square root, Andrew, what do we have?
Greater or equal to 0?
Yeah, it's always greater than or equal to 0. And this was not this last quiz, but quiz 11 that you all, Jimmy's getting back, that you all have back so far. This was pretty much one of the problems on there, but I made it easier. I did 9x plus 4, plus 4, and then, or 4x plus 9, something like that. And then it was a simple solution. Is this simple? No, that's the thing, right? It's not a simple solution. So what do we have to do? We have to recognize that if I factor out x here, I'm left with x squared minus 9. And then that factors further into x minus 3, x plus 3, which yield my critical points. Remember, these are critical points now. These are not my solutions. And if I need to do that, write it on the side. Okay, those are critical points. They're not solutions. So where do I shade? I've got 4 regions here. Excuse me. Where do I shade? It's cubic. I happen to know my cubic graphs. They go like this. That's what cubic graphs traditionally look like. So I can tell you already that the shape of this graph is going to look like this. And what do we want? We want the function to be greater than or equal to 0.
So since it's greater than or equal to, you have open circle on 0 or closed circle on 0.
Mm-hmm.
And it might be going backwards to -3.
Okay, so this region right here, Jimmy?
Yeah.
Inclusively.
Or, yeah, but we keep going past
Are you sure about that, Jimmy?
maybe not.
Can anybody else tell him? Is that...
You cannot.
Yeah, you're going to get... If you check your signs, Jim, you're going to get negative, positive, negative, positive. That's what you'll get. So this also shades this way. So my solution set... Do you want to correct yourself and give us a solution set for it? You can use the board to look at it. You can use set or interval.
3 to 0.
Negative 3 to 0 works. Or from? So negative 3 to 0.
3 to
Okay.
above 3.
Which is up to what's the biggest number we can think of?
Infinity.
And what do I put at the end of that?
Parentheses.
Yeah. So in interval notation, those are the values of x that I can take on to give you a real expression. Where did I get these symbols? Negative, positive, negative, positive. Because it could look like magic if you don't remember what I did. Sean, do you remember?
Plugging back in
Where, Sean?
into the most simplified equation.
So right here. See this right here? Take a value in this region and plug it into these 3 factors. So do it with me real quick if you have to. Take a 4. Am I wrong? I see hands up. Is there
No,
correction?
you're
Okay.
not
I'm like, did I make a mistake with the bracket? Take a 4 from this region over here and plug it in. You get and remember, I don't care about the number. I care about the sign. 4 is positive. A 4 in here makes this positive. A 4 in here makes this positive. Positive times positive yields a positive answer. That's where this symbol is coming from. And I do the same thing with an integer from each region. And pick the easiest integer possible. 1, 0. The number just above whatever this is, which is why I chose 4. Don't choose a random arbitrary number like 27 and have to do that. It just doesn't make sense logically, right? Nick?
I have a question for 48 on 6-6.
Any other questions on this one right here? You could also give set notation as an answer. Last one? No, this is not a does not equal. This is a range of values, Sean. Like, think about it. This is all the values from negative 3 to 0 and all the values from 3 onward. So it's not like we're saying there's 1 or 2 integers that don't work. None of these integers or values, and none of these values work. So your answer has to be either interval or set notation for sure. Okay, it's only when we have like a specific number, like in the quiz, when it was 9x plus 4 under there, or 4x plus 9, you got x could not equal negative 9 fourths. And that's the only number x couldn't be, which is why you do that. But when it's a range of values that x cannot take on, you state the values that x can take on instead. You see the difference there?
Yes.
It's a really good question, right? You notice that? Sometimes with domain, we state the values it can be here. These are the values that x can be. And other times we state the values x cannot be. Only time we state the values it cannot be is when it's a specific value that x cannot take on, right? Because of a 0 or something like that. You had a hand or no?
Yeah.
Okay.
I have a specific question. Number 3361 and
I did interval notation there. Number, say again?
What do you need on 6 there?
On 6,
2.
2. Okay, I think we did this one already in class, Nick. Oh, no, we didn't. I'm sorry. We did one similar, though. We did one similar. This is a 9. We did this with a plus sign, Nick, in class. This is the question, right?
Yeah.
Yeah, so in class, if you remember, we did this with a plus sign. Anybody want to help me out? What do we do first to start here? Because this is a sum or a difference, and I can't do a square root of both. Remember, I cannot do this. Put big letters if you can. You cannot do this. Right? We all know that by now. That is not true. We cannot do that. So please don't. You can't distribute a square root. You can distribute a square root to a product, but not a sum or difference. Go ahead.
You can, you can factor everything really.
So what do I factor out first?
9.
And it leaves behind?
And then a.
I'm going to do it like this, one step at a time. And then what does that become?
3. I don't know the solution. Oh, the difference is 2 squares.
But does that help me to factor?
No, it does not.
It doesn't. So it's tempting to use difference of squares here because people see this and want to do a plus b, a minus b. But those aren't the same things, right? So we cannot do
Factor
that.
out 9, I guess.
We could definitely factor out the 9 separately. So instead of writing it like that, let me write the 9 without the square root there, of course. Separately there. So I can do that. But that's really as far as I can go after the 9. The 9 becomes a 3.
And then you can factor out a.
No, that's it.
Can you do a and b?
What's the rule, Andrew? Look at the top. So look at the rule at the top. You tell me.
Okay.
We just said you can't do that, remember? So it's so tempting to want to say this becomes A and this becomes B. But this is a difference. A difference cannot get the square root applied to each term in the difference, or sum. Sums and differences cannot work the way products and quotients can with square root symbols. John.
For the last one, is it okay if I put the answer in the notation of x is greater than or equal to negative 3, x is not equal 1, x is not equal 2?
number C.
Section 6.1, number 33C. And Sean, I should have said when it's an equation where it's in the denominator, it's a specific value. Because even on the quiz, it was still greater than or a greater than or equal to symbol that was used there. So even on the quiz, it was still set notation there as an answer. Specifically, Sean, just to clarify that, you would want to have it like this, right? Where you had like that. And in this case, x cannot equal negative 5/2. That's where we draw a restriction to our domain versus stating the interval that it can take on. All right, so 33C says the cube root of x minus 1. And we want this expression to be a real number, right? The cube root of any number is a real number. So the answer is all real numbers. Remember, what's the cube root of 8?
2.
And the cube root of negative 8?
2. Nope, nothing.
It's negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. Remember, cube roots can be taken of negative numbers. The rule in general is what? What is the general rule that we apply for positive and negatives? Bridge?
If it's odd, then it can be a negative. If it's even, it has to be.
So this can be plus or minus if it's an odd, but if it's an even index, this has to be positive. Great job, Bridge. Okay? Pick up on that. So this is a fifth root, and this were negative 32. The answer is just negative 2. Because 2 to the fifth is 32, so negative 2 to the fifth is negative 32. So this works for odds if it's negative, not for evens. Gus?
So when you say that, are you saying the root inside the radical will be positive or negative, or neither?
What I'm saying is that the inside of the radical has to be positive if it's an even index.
And it also has to be
the even when you
Like, the square root has to be even if it's an expression.
the power for the
Like, if that was a positive 64, it would have to be a positive 8, right?
yes, and remember that's because we're taking the principal square root. It's technically plus or minus though. Remember, if you solve the equation, if you solve this equation, right, your answers are plus or minus 8. But if I simply, as you said, just do root 64, the answer is simply 8, right? Simplification of an expression yields a principal square root. Answering an equation, we have to have two answers because it's x squared. So the answers are plus or minus 8. But what I'm saying is that this cannot be negative here, or else it becomes imaginary.
Yeah.
So when we do these kinds of problems with find the values of x and make this real, if this is odd, the answer is always all real numbers work, because it can be negative or positive. If this were even though, we have to set the radicand greater than or equal to 0, which is what I'm saying here, to be positive. Or 0, obviously, in that case. Yeah.
I have a question.
Good.
Okay, so it's problem 1 in 6.5b.
All right, finally 6.5. First one from 6.5 here. 6.5 is not a tough one, but it's a lot of bookkeeping. I use that phrase sometimes, bookkeeping. You got to make sure that as you go through your process, you're not making any careless mistakes. Number 20, there are 2 questions for it, right? It says a radical equation and a linear equation are both given. Solve the radical equation by squaring both sides. Solve the linear equation without squaring both sides. So let's start with the radical equation first. To solve this, we get rid of the 3 and isolate the radical. And then we square both sides, and we get x equals 16. Is that fair?
Yeah.
All right. And then part B says the following. And to do this, it says without squaring both sides. And that's a good technique. You don't want to square both sides. If you square both sides, you get x squared times 3 equals 144. And then you got to solve and then re-square root it. It doesn't make sense to do that, which is why the text is telling you it here. So instead, get rid of the radical. And then just rationalize.
Oh.
Okay? Does that make sense, John?
Mm-hmm.
Any other questions on this one here? Go ahead.
For the part A, why wouldn't it be plus or minus? Is it just because you can't?
You're not square rooting. What are you doing?
Oh, you're squaring it. Oh, okay.
Remember, when you square it out, the answer is always,
Positive.
always, no matter what math you do, forever. When you square it up, but when you square a real number, so when you square imaginary numbers, you actually get negative.
So I kind of got it, but I then multiplied 16 by 3.
Here?
Yeah.
But didn't you get rid of the 3 starching?
I
Remember, the goal of 6.5 is to isolate the radical. So when I see the radical next to 3 here, I divide by 3 first and get the radical by itself.
Oh.
Instead of square both sides.
What I did is I squared both sides and then I only asked
Wait, why not last time?
If you square both sides, you get 9x. You have to square this and square this and square this.
Yeah, I didn't square 3.
So we got to remember 2 things. First, period 4 or period 6, you want to come by to your quiz in the Logic Center. Or right after school. Also, we'll have office hours right after school. I haven't heard from anybody that's in a musical program, so I don't know about when you're going to be here. So talk to me at some point today. John, I need to hurt you.
Oh, wait, sorry.
So you save the file somewhere, and you go to the Google Drive website, and you just upload it to the website. Don't worry about it too much right now. I'll talk to you more about it tomorrow if you want help on that. We can do it together.
Okay.
Not too concerned about that right now, so you're working have to do with the break though, for sure. Okay?
When I come as 6th period, can I ask you my quiz?
Yeah, I'll have that for you. So come in, go to the Logic Center, just grab a seat somewhere in the room, find your quiz will be there, it'll be blank. Take your quiz, do it, and get the other quiz to go.
You better ask.
What'd you call?
I said he better ace it.